Good evening. In continuation with the previous session, today we are going to discuss on reflection. What is reflection? In context with the wireless communication, reflection refers to the phenomena where radio waves encounter an obstacle on boundary and boundaries of it, changing direction. These reflected waves can interfere with the original signal, leading to variations in signal strength and quality of the receiver. The key points about the reflection in wireless communication includes reflection surfaces, angle of incidence and reflection, multipath propagation, fading, diversity techniques, delay spread, signal quality. Let us see one by one in brief. Reflection surfaces. Reflection. This can occur when the radio waves encounter surfaces such as buildings, walls, mountains, bodies of water, or the ground. The extent of reflection depends on the material, shape, and the angle of incidence to the surface. Next one is angle of incidence and reflection. The angle at which the radio waves strikes the reflecting surface, which is simply noted as angle of incidence, determines the angle at which it reflects back, that is angle of reflection, following the law of reflection. For smooth surfaces like mirrors or calm bodies of water, the angle of reflection is equal to the angle of incidence. Next one is multipath propagation. Reflection contributes to the multipath propagation, where multiple copies of the transmitted signal reach the receiver through different paths. These multipath signals can interfere constructively or deconstructively at the receiver, leading to fading or variations in signal strength. Fading, what is it? Reflection induced multipath propagation can result in either fading or constructive waveform, where the signal strength varies rapidly over time or space or distance. This fading can be caused by constructive or deconstructive interferences among the multipath components. Next one is diversity techniques. To mitigate the effects of fading caused by reflection, diversity techniques such as antenna diversity, frequency diversity, or space diversity are often employed. These techniques use multiple antenna frequencies or spatial paths to improve the reliability and robustness of the wireless communication link. Delay spread. Reflections from distant objects or surfaces can introduce delays in the received signal, leading to spread in the arrival times of multipath components. Signal quality. Reflections can impact the quality of the received signal, causing signal distortion, intersymbol interference, or even complete signal loss in severe cases. So these are the brief about reflection. What actually the reflection, how it can be understood? As discussed now, it occurs when a radio wave propagating in one medium impinges upon the another medium having different electrical properties. If the radio wave is incident on a perfect dielectric, part of the energy is reflected back, part of the energy is transmitted. In addition to the change of direction, the interaction between the wave and the boundary causes the energy to be split between reflected and the transmitted wave. The amplitudes of the reflected and also the transmitted waves are relative to the incident wave amplitude by Fresnel refraction coefficients. So these are the pictorial representation of vertical and horizontal polarization. See, the first picture clearly duplicates the vertical polarized waves, the normal field and also the electric field and the magnetic field, which is at right angles to each other. and the radio wave is recorded with respect to the distance. The second image represents the horizontally polarized wave, and here also the electric field and the magnetic field are perpendicular to each other. Reflection in dielectrics, how the reflection varies in a dielectric medium. Dielectric medium, it can be considered as two medium with different dielectric properties or values. One may be air, another may be the water. Here, the E field in the plane of incidence has been represented with the help of the incident wave and the reflected wave, and a part of the wave is being transmitted. Similarly, in picture B also, you can infer the incident of the wave and reflection of the wave, which is normal to the plane of incidence, and also a part of the wave is being transmitted to the another medium. Reflection. Reflection is a parameter which can be represented by the symbol shown here, which is E reflected divided by E incident, and the eta is the reflection coefficient of first medium minus the reflection coefficient of the angle of incidence of the second medium divided by the sum of those two. This is for parallel E field polarization. Coming to the perpendicular E field polarization, there is a slight difference between the denominators. The numerator is same as that of the parallel E field polarization, whereas the denominator is the incident angle plus the reflection coefficients. These expressions express ratio of the reflected electric fields to the incident electric field and depend on the impedance of the media and angles. Characteristic impedance eta is always represented by the square root of the ratio of permeability and permittivity. Mu is permeability, epsilon is permittivity. Reflection in perfect conductor. So far we were discussing on reflection between a dielectric medium, how the waves behave in a perfect conductor. If a wave is incident on a perfect conductor, the entire energy is reflected back. Here we have the reflected angle theta r is equal to incident angle. Complete wave has been reflected back. And the amplitude or the E field EI is equal to ER in the plane of incidence. And E field is normal to the plane of incidence. Either EI is equal to minus ER. If it is in the same plane, it is equal, and if it is in the perpendicular, then the magnitude is opposite to each other. And if the value is in the same plane or parallel, then E is equal to 1. That is, the magnitude is same. If it is perpendicular, the magnitude is negative of the original value. Next, we will discuss on reflection in Brewster angle. It is what? What is a Brewster angle? It is an angle at which no reflection occurs in the medium of origin. It occurs when the incident angle theta b is such that the reflection coefficient is equal to 0. It is given in terms of theta b. Sin theta b is equal to epsilon 1 divided by epsilon 1 plus epsilon 2 square root. When the medium is a free space and the second medium has a relative permittivity of epsilon r, then sin theta b is equal to epsilon r minus 1 divided by epsilon square minus 1.